121 degrees in Canada. Let that land for a moment. Not in Death Valley, not in the Sahara, in Canada, a country whose national identity is practically built around cold, around hockey ponds and frost, and the kind of winter that turns your breath into fog. And on June 29th, 2021, a small town in British Columbia recorded the highest air temperature ever measured anywhere on Canadian soil. Not by a fraction. By a margin that left climate scientists genuinely speechless. The town was called Litton. By the following afternoon, Litton was on fire. The same ridge of high pressure that baked the town to an all-time national record also turned the surrounding landscape into tinder dry enough to catch within hours. A wildfire moved through the village so fast that most residents escaped with only what was in their hands. Most of the town burned. The place that had just set the record ceased within 24 hours of setting it to meaningfully exist. More than 1,400 people died across the Pacific Northwest and Western Canada that week. Most of them quietly, indoors, in homes that had never needed air conditioning, in a region that had never thought it would. Now it is summer 2026. A ridge of high pressure is building over the exact same ground. Forecasters are once again reaching for the word record, and the question forming on every weather watcher's screen is the same one nobody wants to ask out loud. Is this how it starts again? The honest answer is not a yes. It is also not a simple no. It is something more useful than either, and it lives in the gap between a temperature reading and a death toll. A gap that almost nobody thinks about. A gap that in 2021 turned a heatwave into the worst natural disaster in the region's modern history. A gap that, once you understand it, changes the way you read every hot weather forecast for the rest of your life. This is the story of two skies that look nearly identical on a weather map and mean almost opposite things. One of them is arriving this weekend. The other one killed over 1,000 people. The difference between them is not the kind of difference you can read off a thermometer. You have to know where to look. Part 1. The week that switched. 10 days ago, Seattle was cold. Not autumn cool, not early spring mild. Cold in the way that made people reach for jackets in June, run their furnaces past the date they normally would have shut them off, complain in the way Pacific Northwesterners always complain in a cool June, that summer was never going to show up, that this was it, that this was just what the region was now. The numbers backed them up. Early June 2026 was running as one of the coldest starts to the month the Pacific Northwest had recorded in roughly 40 years. The thermometers in Seattle were sitting in the upper 50s. Portland was grey and damp and thoroughly unimpressed with a calendar insisting it was summer. Then the atmosphere changed its mind. On the morning of June 11th, the National Weather Service office in Seattle inserted a single sentence into its forecast discussion. That sentence is the reason we are here. Record high temperatures, the forecasters wrote, are likely both Sunday and Monday. Not possible, not worth monitoring. Likely. The same ground that had been edging toward near-record cold in the first days of the month was now, less than 2 weeks later, being told to prepare for record heat. That is not a seasonal drift. That is a violent reversal, and reversals of that speed and magnitude do not come from nowhere. They come from a specific atmospheric structure releasing stored energy, snapping from one locked configuration into another. When you see a swing like that on the chart, the rational question is not whether something unusual is happening. It is how unusual and how dangerous. The answer requires understanding what was sitting over the entire continent in the weeks before, because the Northwest did not experience this reversal in isolation. It was the last piece of a continental-scale puzzle to click into place. While Seattle shivered through the first half of June, the eastern United States was enduring the first real heat siege of summer. Heat advisories stretched from Washington, D.C. up through New England. Records were falling along the mid-Atlantic coast. At the same time, the center of the country was getting hammered by back-to-back severe weather events. Tornado watches rolling through Iowa and Illinois, destructive wind events knocking out power across Missouri and Indiana, a stretch of storm activity that any meteorologist would describe as relentless. 3 completely different crises, 3 completely different experiences, all produced by the same atmospheric configuration. The jet stream had buckled into a high-amplitude, slow-moving wave pattern and stalled. Where the jet bowed northward, you got the heat dome, sinking air, no relief, record temperatures. Where two wave troughs plunged southward, flanking that heat dome, you got the volatile collision zone that kept spinning up storms across the middle of the country. And far to the west, underneath the opposing side of the same jet stream pattern, the Pacific Northwest drew the cold ticket. It sat under a trough while the rest of the continent baked or burned. Blocking patterns do not hold perfectly still forever. The waves drift. Over the past week, the trough anchored over the northwest has flattened and shifted eastward, and right where the trough was, a ridge of high pressure has begun to build. The cold side became the warm side. The whole machine simply rotated. That rotation is the entire story of this weekend's heat event, and it is also the key that connects this weekend to the catastrophe of 2021. Because the same basic structure, a blocked jet stream, a ridge building over the northwest in early summer, the marine air shoved offshore, is the same structure that ran in 2021. The only question that matters is how powerful this particular version turns out to be. And here is the genuinely surprising thing. The honest answer to that question, based on what the forecasters are actually seeing right now, is significantly less alarming than the shadow this ridge is casting. Not because the heat is nothing, it isn't, but because the way the numbers fall and where they fall puts this event in a different category than the one everyone is understandably comparing it to. To understand why that comparison both reassures and warns at the same time, you have to go back to 2021 and walk through it properly. Because the death toll from that week was not produced by heat alone, it was produced by a specific combination of factors that most weather coverage completely fails to explain, and most people never think about until the next time they need to. Part 2. The mechanics of the reversal. Before we get to 2021, spend a moment on the machinery driving this weekend. Because the mechanism is the whole story, and watching it in action, even in a smaller and more manageable form, is the only way to understand what the dangerous version looks like. The ridge that is now building offshore and sliding east toward Washington is doing exactly what all Pacific Northwest summer ridges do, pressing air downward, air that sinks warms as it descends, a consequence of basic compression physics that has nothing to do with the sun. That sinking air also dries out. So the marine clouds that normally park over the coast, acting as a natural cooling blanket, thin out and disappear. The sun lands on clear ground. This alone would produce a warm day. But the ingredient that turns a warm day into a record is the wind shift. As the upper level high strengthens and its axis swings east over western Washington, a secondary feature develops along the coast, a small area of low pressure expected to form Saturday night. That coastal low, modest, easy to overlook on a weather map, is the trigger mechanism. When it forms, it flips the surface wind direction. Instead of the onshore flow that normally carries cool Pacific air inland, the surface wind begins moving offshore, from the hot interior out toward the sea. That offshore flow is the key that most coverage misses entirely. The Pacific Ocean just off the Washington and Oregon coast is cold, genuinely cold. Sea surface temperatures there regularly sit in the 50s, Fahrenheit even in summer, cold enough that the marine air it generates acts as a natural air conditioner for the entire region during westerly flow. When the flow reverses and turns offshore, that air conditioner gets switched off. The coast loses its coolant supply. The interior valleys then heat freely, without anything left to cap them. Forecasters in the Pacific Northwest watch for this offshore component the way a physician watches a critical vital sign. A westerly wind off the Pacific limits the afternoon peak no matter how strong the upper level ridge is. An easterly or northeasterly offshore flow removes the limiter and lets the ridge express its full strength, all the way down to where people live and breathe and try to sleep. This is why the word record appears in the forecast, even though the ridge itself is only moderately strong. The record is not coming from an historically extreme air mass. It is coming from the wind setup that will strip away the last natural defence the region owns. The resulting forecast numbers look, at first, almost mundane. Highs in the middle 80s to low 90s on Sunday, 88 to the middle 90s on Monday, with Seattle forecast to reach 91 degrees at its peak. In Phoenix, those are February temperatures. In Dallas, they barely merit a mention. In Seattle, in the middle of June, 91 degrees is genuinely unusual. The city has recorded temperatures above 90 on fewer than 276 days across its entire recorded history. Of those, only about 7%, fewer than 20 days total have happened this early in the calendar year. So while the number sounds modest to most of the country, it represents an outlier for this place and this time, which is exactly why forecasters flagged it as record challenging. The heat risk classification the Weather Service issued reflects this local context directly. Moderate heat risk for most of the regions Sunday and Monday. A 30 to 50% chance of major heat risk in the southwest interior of Washington and in the lower Chehalis Valley, the inland pockets where the offshore flow does its most efficient work and the valleys trap the most heat. The overnight lows, and this is the number that will matter more than any afternoon peak, are forecast to drop back into the mid-50s to low 60s. That single figure is the most important one in this entire forecast. We will come back to exactly why that is, repeatedly, because it is the hinge on which the entire comparison to 2021 turns. For now, file it away. Mid-50s at night. That number is doing a great deal of work. Part 3. Acclimatization and the June problem. There is a timing factor underneath this forecast that tilts the danger upward, even as the temperature keeps it below panic territory. It is called acclimatization, and it is the quiet reason an early season heat event consistently punches above its weight class. The human body does not respond to heat the same way at the beginning of summer as it does at the end. Over the course of 1 to 2 weeks of heat exposure, the cardiovascular system adapts. The heart becomes more efficient at moving warm blood to the skin's surface, where it can radiate heat outward. Sweat glands become more responsive, triggering faster and producing more volume. The sweat itself changes in composition, becoming more dilute and conserving electrolytes. Blood plasma volume increases slightly to support the whole system. A person who has gone through this adaptation can handle a 90-degree afternoon in a way that would genuinely strain the same person before acclimatization happened. The adapted body handles the same heat load with measurably lower cardiovascular stress. The adapted body is, physiologically, a different machine. The catch is that this adaptation fades when the heat goes away. Every season it has to be rebuilt from scratch over that same 1 to 2 week exposure window. And this June, after weeks of near-record cold across the Pacific Northwest, the entire population of Seattle, Portland, and every inland valley underneath this ridge has built none of it. Their bodies are still set, in a very real cardiovascular sense, to winter. A 91-degree day landing on unacclimatized bodies in unacclimatized homes hits harder than the same 91 degrees would in August. The acclimatization issue is one of the 3 hinges the comparison to 2021 turns on. The other 2 are the peak temperature, substantially lower this weekend than in 2021, and the overnight lows, forecast to stay cool this weekend, catastrophically warm in 2021. Understanding all 3 together is the only way to read this forecast correctly. Before we can score that comparison properly, though, you have to understand what 2021 actually was. Not as a headline, not as a number on a thermometer, as a mechanism, because it is the mechanism that produced the death toll, not the peak temperature alone, and the mechanism is what you have to watch for. Part 4. The week. The Northwest broke the pattern that built over the Pacific Northwest in the last days of June 2021 looked familiar to the meteorologists watching it develop. A ridge of high pressure, an offshore flow developing, the marine layer retreating, the same ingredients that produce heat events in this region every few years. What was not familiar was what the computer models began printing. As the ridge amplified in the days before the peak, the temperature forecasts aloft, the upper air temperatures that drive surface heat, climbed to values the forecasters initially questioned. Model run after model run produced readings so far above anything in the regional record that the people tasked with translating those numbers into public warnings had to actively work through their own disbelief. Their instruments and models were not broken. The numbers were real. The event was simply going somewhere the models had almost no historical precedent to reference. The reason was the sheer vertical reach and strength of the ridge. The warmth it was pumping into the upper atmosphere above the Pacific Northwest reached a level that had effectively never been observed over that region before, and when a ridge is that tall, that warm aloft, the compression heating as air sinks reaches the surface with proportionally greater force. The ceiling the event could theoretically reach kept rising in the model guidance. And then, over 3 consecutive days in the final week of June, the numbers it produced stopped looking like forecast output and started looking like data entry errors. Portland, Oregon reached 116 degrees Fahrenheit on June 28th. Portland, a city famous for rain, for grey skies, for the kind of mild summers that make the Pacific Northwest's outdoor culture possible, shattered its all-time temperature record by margins that had never been seen in records that stretched back well over a century. The previous record fell and the new reading sprinted past it. Seattle climbed to 108 degrees, its highest temperature ever measured, on the same day. For context, a significant majority of Seattle homes had never had air conditioning installed because historically they never needed it. The city's entire climate history said air conditioning was an expensive solution to a problem that simply did not exist there. The summer of 2021 rewrote that history in a matter of hours. And then there was Litton. The village sits in a canyon in the interior of British Columbia, a few hours north of the Washington border. On June 29th, it recorded 49.6 degrees Celsius, 121 degrees Fahrenheit, the highest air temperature ever measured anywhere in Canada. Full stop. Not the highest for June, not the highest for British Columbia, the highest ever recorded on Canadian soil, period. By a margin that made scientists go back and check their equipment multiple times before accepting the number. The following day, Litton caught fire. The landscape around the village had been baked to such dryness that when a fire started, it moved faster than most residents could react. Most of the town burned. The place that had just set the national heat record was, within 24 hours, largely gone. When scientists later tried to situate the event within statistical climate models, the models strained to accommodate it. The analysis that emerged placed the heat dome somewhere in the range of a 1 in 1,000 to 1 in 10,000 year occurrence for the climate of that era. In plain terms, the event was not supposed to be possible within the bounds of what the regional atmosphere had ever produced. The death toll confirmed the scale of the catastrophe. More than 1,400 people died across the United States and Canada during the heat dome week. In Oregon alone, confirmed heat-related fatalities numbered at least 116, with 72 of those in Multnomah County, which encompasses Portland. At least 112 people died in Washington. In British Columbia, estimates reached approximately 800 deaths, the overwhelming majority in the western part of the province. The pattern in the deaths was consistent and heartbreaking, and, once you understand the physiology, entirely predictable. The people who died were overwhelmingly older. Overwhelmingly living alone. Overwhelmingly in homes without air conditioning. Many were found days later by family members or neighbours who had not been able to reach them. They were not doing anything reckless. They were sitting in their own living rooms as the heat accumulated around them with no exit. Here is the critical fact that most coverage of the disaster failed to adequately explain. Those people did not die because a single afternoon reached 116 degrees. They died because of what happened at night. Part 5. Why the Nights Kill. The human body manages heat through two primary mechanisms. It pushes warm blood toward the skin, where the temperature differential with cooler surrounding air allows radiation of heat outward, and it sweats, using evaporative cooling to shed heat that radiation alone cannot handle. Both mechanisms have limits. Radiation becomes less effective when the surrounding air temperature rises, because the temperature differential that drives heat transfer narrows. Sweating becomes less effective when the air is highly humid, because the air cannot readily accept additional moisture. In the Pacific Northwest, the air is typically dry enough that sweating works well. This is one of the region's genuine advantages during heat events. But both mechanisms share a common dependency. They require the surrounding air to be cooler than the body, and cooler by enough margin to accept the heat the body needs to offload. When the air never cools significantly, when nighttime temperatures stay close to afternoon temperatures, the body runs a continuous heat deficit. It gains heat faster than it can shed it. Core temperature begins to drift upward. A rising core temperature places the cardiovascular system under escalating stress. The heart pumps harder and faster to maintain blood flow to the skin. The kidneys begin to strain as the body loses fluids to sweat. In an older person, someone with cardiovascular disease, or someone on certain common medications, blood pressure drugs, some psychiatric medications, antihistamines, the system has less reserve to absorb this strain. What begins as discomfort on day 1 becomes physiological crisis by day 3 if no nighttime relief occurs. This is the precise mechanism by which warm nights transform heat waves into mass casualty events. The afternoon heat opens the wound. The warm night prevents it from closing. Each subsequent day stacks new heat on top of unresolved heat from the days before. The compounding is exponential in its effect on human physiology. In 2021, the nights did not cool. The ridge was so strong and so locked in position that overnight temperatures across much of the region stayed far above normal, in some locations never dropping out of the 80s. The safety valve the Pacific Northwest depended on, the reliable nightly flush of cool ocean air through open windows, was broken. Houses that might have been livable at 11 in the morning were ovens by 11 at night, and hotter still the following morning, day after day, with no reset. That is why the overnight lows are the number I keep returning to throughout this analysis. They are not a footnote, they are the central mechanism. An afternoon peak of 116 with cool nights is dangerous but survivable for most people. An afternoon peak of 116 with nights that stay in the 80s is a compounding catastrophe. Now hold that framework against this weekend's forecast. The overnight lows are projected to fall back into the mid-50s to low 60s. That is a number that lets the body reset. That is a temperature at which a house with no air conditioning can flush the accumulated heat of the afternoon by simply opening its windows after dark. That is the safety valve intact and functional. This single factor, the predicted coolness of the nights, is more reassuring than the lower afternoon peak alone. It means the compounding mechanism that wrote the 2021 death toll does not have the fuel it needs to operate. Bodies will recover, houses will cool, the physiological debt that accumulated through the day will be repaid by morning. But here is the edge of that reassurance that nobody should let pass unexamined. The nighttime relief only helps if people use it. A population wired for years to treat Pacific Northwest summers as mild, a population that spent the first 2 weeks of June running their furnaces, is exactly the population least likely to take a 91-degree forecast seriously. The same cultural assumption that made the region's housing stock historically sensible, that cool nights would always come, is the assumption that gets people killed when the nights stop cooperating. This weekend, the nights cooperate, so the cultural assumption happens to be correct. But the assumption and the correctly performing nights are two separate things, and understanding that separation is the entire point. Part 6. Why the Northwest specifically. Other places on Earth routinely reach the temperatures that killed in the Pacific Northwest in 2021. Phoenix hits 116 degrees, and life continues. People drive to air-conditioned offices, children go to schools with climate control, nobody dies in their living rooms. The same temperature, in a different city, produces a different outcome. The question of why requires examining something deeper than the weather. Start with the most straightforward fact. By every available metric, the Pacific Northwest is the least air-conditioned major region in the United States. This is not a failure of foresight or resources. It is the entirely rational product of a climate that, for generations, genuinely did not require air conditioning. A homeowner in Houston has no choice. Without air conditioning, the house is unlivable for 6 months of the year. A homeowner in Seattle, through most of that city's climate history, faced perhaps a handful of warm afternoons per year, reliably followed by cool nights that flushed the accumulated heat away by morning. An air conditioner was a significant expense for an appliance that would sit unused 51 weeks out of 52. Multiply that individual calculation across millions of households over many decades, and you get the housing stock the region has today, built for a cool maritime climate, insulated for winter heat retention rather than summer heat rejection, furnished without air conditioners because the regional climate never demanded them. At the time of the 2021 heat dome, Seattle had the lowest percentage of air-conditioned households of any major metropolitan area in the United States. Portland had the third lowest. When the heat dome descended on the region, it descended on millions of people with no mechanical way to cool the air around them. They had fans, which circulate hot air rather than cooling it. They had open windows, which in offshore flow conditions admit warmer air rather than cooler. They had cooling centres, which were overwhelmed almost immediately as demand exceeded capacity across the entire region simultaneously. And they had the hope that the night would cool down, the same hope that the ridge, in its stubborn locked strength, refused to allow. The second factor is the urban heat island, the measurable warming effect that dense cities create through their own physical infrastructure. Pavement, concrete, brick, rooftops. All of these materials absorb solar radiation during the day and release it slowly after dark. A dense urban neighbourhood can remain several degrees warmer overnight than the surrounding countryside, simply because the built environment stores and re-radiates heat more efficiently than soil and vegetation. That extra warmth is exactly what prevents the nighttime recovery, and it falls hardest in the densest, lowest income neighbourhoods, the ones with the least tree cover, the fewest parks, the most continuous impervious surface. In 2021, temperature maps of Portland and Seattle confirmed this. The urban cores were measurably hotter at night than the surrounding suburbs, and the mortality maps reflected it. The social dimension of heat vulnerability runs through the same geography. Older adults, more vulnerable because the body's thermoregulatory capacity genuinely declines with age, and because the subjective sense of thirst that triggers fluid intake becomes less reliable, were overrepresented dramatically in the 2021 death toll. People living alone were overrepresented because there was no second person to notice early heat exhaustion, insist on going to a cooling centre, or check on a roommate who had not emerged from the bedroom in 2 days. People on certain common medications, diuretics, beta blockers, certain antidepressants and antipsychotics, were overrepresented because those medications can blunt the cardiovascular response to heat or interfere with the sense of thirst. And people in lower income brackets were overrepresented for the simplest of reasons. They were least likely to have air conditioning, least able to afford running it continuously if they did have it, and most likely to live in the hotter, denser parts of the city where the urban heat island effect was strongest. The deaths were not randomly distributed. They concentrated in overlapping groups of people who were physiologically more vulnerable, socially more isolated, and physically least equipped to manage extreme heat. This is the pattern that heat disasters everywhere produce. The same signature appeared in the European heat catastrophe of 2003, which killed tens of thousands across France and Italy and Spain and Germany. It appeared in the Russian heat event of 2010, which killed tens of thousands more, in a country that had also never built its cities or its housing stock around summer heat defence. The common thread across every one of those disasters is not simply how hot it got. It is the collision of a heat event with a population that had no infrastructure to absorb it, sustained for long enough that bodies could not recover between days. Magnitude, meeting vulnerability, sustained by duration, and warm nights. That triad is the mechanism. 2021 was its clearest demonstration in the Pacific Northwest, and the reason that demonstration matters for every subsequent summer, including this one, is that 2 of the 3 components of the triad, vulnerability and the potential for warm nights, have not changed at all. Part 7. The machine that controls the dials. To understand both the reassurance and the warning embedded in this weekend's forecast, you have to understand the atmospheric structure that produced both this event and 2021, because they are not unrelated weather events. They are outputs of the same machine in different gear settings. That machine is the jet stream. The jet stream is a narrow band of fast-moving air in the upper troposphere that flows, in the broad sense, from west to east around the northern hemisphere. It is driven by the temperature contrast between the cold polar regions and the warmer mid-latitudes. Cold air sinks and flows outward at the surface. Warm air rises and converges aloft, and the rotation of the Earth bends those flows into the west to east river that pilots use to reduce fuel consumption on transcontinental flights. When the jet stream flows fast and relatively straight, it acts as a conveyor belt for weather systems. Storms develop, move, decay, move along. No single place gets stuck with the same conditions for long. Temperature swings happen gradually as different air masses cycle through. But the jet stream is not a rigid pipe. It meanders. And sometimes those meanders grow large, the waves amplifying into enormous loops that bulge far northward in some longitudes and plunge far southward in others. When those waves grow large enough and slow enough, the conveyor belt effectively stops. Weather locks in place. What meteorologists call a blocking pattern has formed. Wherever the jet stream bows northward, high pressure builds underneath it. Sinking air, clearing skies, persistent heat. The ridge. Wherever the jet plunges southward, low pressure pools, rising air, unstable weather, storms, the trough. And the places that land under either feature stay there, sometimes for weeks, while the pattern holds. This is the configuration that sat over North America through most of June 2026. a sprawling high-amplitude blocking pattern, the eastern US under the heat ridge, the central states in the volatile collision zone between the heat and the polar air, and the Pacific Northwest parked under the western trough. All of it from one jet stream configuration that refused to move. When the block finally began to loosen and the waves started to shift, the Northwest drew a new ticket, the ridge slot. The same mechanism that had kept it cool for weeks now set the stage for record heat. The speed of that transition is the atmosphere's way of showing its hand. When the weather changes that fast, it is because a large-scale pattern released its grip and snapped into a new one, dumping stored energy into whatever region happens to be in the path of the reorganization. The difference between this weekend's ridge and the 2021 ridge is not a difference of type, it is a difference of scale and stubbornness. The 2021 ridge built to an amplitude, a height and warmth aloft, that had essentially never been observed over the Pacific Northwest in the instrument record. The anomaly at the 5,000-foot level above the surface climbed to values that left the region's statistical distribution for summer heat events in the dust, which is why the statistical studies afterwards assigned it return intervals in the thousands to tens of thousands of years. The ridge was simply bigger than anything the region's records had produced before, and it locked. Instead of drifting through over a couple of days and allowing the marine air to return, the 2021 ridge parked itself over the region for the better part of a week. That is the word that decides whether a heat event produces discomfort or catastrophe. Lock. A ridge that moves through produces a spike. Temperatures climb, peak, then fall back as the marine air returns. A ridge that locks produces a siege. Temperatures climb, hold, climb further as the heated ground re-radiates into the heated air, hold again, compound through days that all start hotter than the last because the nights never discharge the accumulated warmth. The duration is not a secondary concern. In the context of heat deaths, the duration is often more important than the peak. A 100-degree day, embedded in a week with cool nights, is a stress event. A 90-degree week where the overnight temperatures never drop below 75 is potentially catastrophic, because the physiology of heat harm runs on accumulation, not on peaks. The ridge building this weekend is neither historically tall nor positioned to lock. The forecast shows it peaking Sunday and Monday, and then relaxing as the pattern shifts and the marine air returns early in the new week. It is a 2-day event, a visit, not an occupation. There is an active line of research, genuinely debated among scientists, not settled, that asks whether human-caused warming may be changing the jet stream in ways that favour more of these high-amplitude blocking patterns. The scientific reasoning runs roughly like this. The Arctic is warming approximately 4 times faster than the global average. That rapid warming reduces the temperature contrast between the polar regions and the mid-latitudes. Since that temperature contrast is part of what keeps the jet stream flowing fast and relatively straight, a smaller contrast may produce a slower, more meandering, more easily stalled jet, the kind that buckles into the large blocks and holds them in place. The hypotheses attached to this idea carry technical names: quasi-resonant amplification, low-phase speed Rossby wave packets. The core implication is that a warming world may generate more of the stuck high-amplitude patterns that produce events like 2021 more frequently. I want to be clear about the scientific status. This is not a settled finding. There are credible researchers who argue the signal is not yet distinguishable from natural variability, or that other factors dominate. What can be said honestly is that the hypothesis is taken seriously by serious people, that there is real evidence pointing in its direction, and that if it is correct, the machine that just rotated the Pacific Northwest from record cold to record heat is being slowly tuned toward producing the lethal version of that rotation more often. That is a different and more durable concern than any single weekend's forecast. But it connects this weekend to the larger pattern in a way that honest weather communication should not skip over. Part 8. The comparison by the numbers. Now the analysis can do what it has been building toward. Put 2021 and this weekend side by side, category by category, and produce an answer to the question that holds up under examination. Category 1. Peak temperature. 2021. Portland 116 degrees, Seattle 108 degrees, Litton 121 degrees. This weekend, Seattle forecast to reach 91 degrees, with the broader region peaking in the low to middle 90s. The gap is 15 degrees in Seattle, 25 degrees in Portland's comparison, 30 degrees at the extreme. In the context of temperature records where historic readings are commonly exceeded by tenths of a single degree, a gap of 15 to 30 degrees is not a marginal difference. It is the difference between an event that breaks records and an event that shatters them by margins that makes scientists double-check their equipment. On peak temperature, this weekend is not remotely in the same category as 2021. Category 2, duration and locking. 2021, the ridge built over multiple days, locked in place, and held for the better part of a week. Daily high temperatures in the affected cities climbed each successive day as the preheated ground and air pushed the next day's peak higher. The event was self-reinforcing. This weekend, the ridge builds, peaks Sunday and Monday, and is then expected to relax as the flow pattern shifts and marine air begins to return. 2 days, not locked. The forecasters are not describing a stalled block. They are describing a mobile ridge that passes through. On duration, this weekend falls decisively short of what 2021 required to do its damage. Category 3, overnight lows. 2021, nights stayed far above normal across the region. In some locations, temperatures never dropped out of the 80s overnight. The safety valve, the nightly flush of cool ocean air through open windows, was broken by the same ridge that drove the afternoon peaks. This weekend, overnight lows are forecast to fall back into the mid-50s to low 60s. The safety valve functions. Bodies get a reset, houses can be flushed. This is the single factor that most sharply separates this weekend from 2021. Not the lower peak temperatures, though those matter. The cool nights. They are the difference between a heat event that accumulates and compounds, and one that produces a difficult afternoon and then retreats. On all 3 decisive categories, peak, duration, overnight lows, this weekend falls clearly and substantially short of the conditions that made 2021 lethal. The plain answer to the plain question: no, the Pacific Northwest is not reliving the disaster of 2021 this weekend, not even close on the factors that drive mass mortality. That is the honest, data-grounded answer, and it should be stated directly rather than hedged into meaninglessness. A 91-degree day with cool nights and a 2-day duration is a real heat event for this region in June. It is not a catastrophe. Now comes the edge. Category 4, early season timing and unacclimatized bodies. 2021, late June. The population had experienced no sustained warm weather before the event. This weekend, mid-June, after an unusually cold early June. The population has experienced even less warm weather acclimatization than the 2021 population had at this same calendar point. On this factor, this weekend is identical to 2021. The same unacclimatized physiology, the same cardiovascular system still running in winter mode, the same heat load landing on bodies that have had no time to adapt. Category 5, structural vulnerability, housing stock, absence of air conditioning, cultural habits. 2021, the least air-conditioned major region in the country, homes built for maritime cool, a population culturally trained to treat heat as novelty. This weekend, exactly the same. Nothing about this has changed. Homes cannot be retrofitted at scale in 5 years. Cultural calibration does not reset after a single disaster. The same people are in the same buildings with the same absence of mechanical cooling. These 2 factors, the early season timing and the structural vulnerability, are unchanged between 2021 and this weekend. The only reason they stay quiet this weekend is that the ridge is too small and too brief to activate them fully. That is the correct framing of the comparison. This weekend is not 2021 because 2 of the 3 lethal ingredients are absent. The cool nights mean no compounding. The lower peak means a smaller initial heat load. But the underlying tinder, the unprotected, unacclimatized population in uncooled homes, is identical. The difference between this weekend and a repeat of 2021 is entirely in the character of the ridge, not in the character of the region. That observation is both reassuring and disquieting at the same time, and it is supposed to be both. Part 9. What repeat would actually look like? There is practical value in naming exactly what the warning signs of a genuine repeat would be, because the whole purpose of understanding 2021 is to recognize the next one before it peaks. A true repeat of the 2021 event would show specific signatures in the forecast days in advance that any informed reader could identify. Signal 1. Upper air temperatures far beyond historical norms. In the current event, the temperature at approximately 5,000 feet above the surface, the 500 millibar level, is forecast to reach around plus 20 degrees Celsius over western Washington at its peak. In 2021, the corresponding values climbed far beyond that, into territory that had no real precedent in the regional record. A forecast showing aloft temperatures in ranges that forecasters are explicitly flagging as historically extreme, not just unusual, but outside of what the models have good calibration for, would be the first signal. Signal 2, model guidance showing the ridge locked in place for many days. When the forecast discussions shift from describing a peak and a return to normal to describing a pattern that holds through day 5, day 7, day 10, that is the duration signal. The locking is what allows the compounding to run. Signal 3, overnight lows forecast to stay anomalously warm. If the forecast shows overnight minimums in the 70s, or, in a worst-case scenario, failing to drop out of the 80s, that is the clearest single indicator that the safety valve is breaking. This is the signal that should change behaviour most urgently, because it means the nighttime recovery that allows people in uncooled homes to survive is no longer available. Signal 4, heat risk classifications climbing to extreme levels across broad regions. A moderate heat risk is routine warning territory. A major heat risk in specific vulnerable areas is a strong warning. When the classifications start reaching the highest extreme tier across wide swaths of the region, not just isolated inland valleys, but entire metro areas, the event has crossed into mass casualty territory. None of those 4 signals is present in this weekend's forecast. The ridge is moderate, not historically extreme. It relaxes after Monday. The nights fall into the 50s. The heat risk stays at moderate with a chance of major in a couple of specific valleys. Every signal points in the same direction. This is the small version, not the lethal version. But those signals are now part of your permanent weather reading toolkit. You do not need a meteorologist to interpret them for you. If you see all 4 line up simultaneously in a future forecast, extreme aloft temperatures, multi-week locking, warm nights, extreme heat risk classifications, you know what you're looking at and you know what it requires. Part 10. The question. The noise drowns out. Every significant heat forecast now generates 2 parallel conversations. The forecast itself and a set of claims about what the forecast is hiding, manufacturing, or concealing. These claims are predictable in their shapes, and dismissing them with mockery only makes them seem more credible to people who are already suspicious. The right response is arithmetic. The most common claim is that the heat is engineered, that some installation or research facility is producing or amplifying these temperature events deliberately. This claim fails on the basic physics of energy. A continental scale ridge of high pressure processes energy on the order of 10 to the 18th power joules per day. Radio frequency research installations operate in the range of a few million watts, which over a full day amounts to something many orders of magnitude smaller. The ratio between the two is not a factor of 2 or 10 or 1,000. It is a factor of many trillions. Asking a radio transmitter to build a continental heat ridge is physically equivalent to asking a single candle to boil the ocean. The energy is not there, and no amount of classified technology changes the fundamental physics. The second claim is subtler, that the forecasts are exaggerated for political or institutional reasons. This claim runs into 2 immovable obstacles. First, forecasts in the Pacific Northwest are not produced by a single institution that could coordinate a false message. They are the convergent output of multiple independent national and international modelling systems, run by different governments on different computational infrastructure, arriving at similar conclusions through different means. A manufactured false alarm would require all of those systems, and all of the meteorologists interpreting them, to coordinate the same lie simultaneously. Second, forecasts are tested by reality within days. When the National Weather Service in Seattle says record highs are likely Sunday and Monday, the thermometers either confirm it or they do not, in public, on the open record in front of everyone. You cannot fake a measurement that the entire population can go outside and check. The third claim is the most reasonable sounding and the most partially correct, that heat waves are natural, they have always happened, and treating a low 90s weekend in June as cause for alarm is manufactured panic. On the narrow factual point about this specific weekend, this claim has merit, which is precisely what I have been saying. A 91-degree day with cool nights and 2-day duration is a real weather event, not a catastrophe. Treating it as the end of days would be wrong. Where the claim breaks down is in its extension from the specific weekend to the broader trajectory. Because the question of whether heat events are becoming more frequent, more intense, and more persistent is not answered by the weather history of any single weekend. It is answered by the data of decades, and the data of decades says something that no serious atmospheric scientist disputes. The temperatures that defined 2021 were, for the climate of that moment, a 1 in 1,000 to 1 in 10,000 year event. Climate attribution science, the discipline that attempts to determine how much a specific extreme event was influenced by human-caused warming, concluded that the 2021 heat dome was virtually impossible without the warming that had already occurred by that point. The attribution studies estimated that warming had made the event approximately 150 times more likely than it would have been in the pre-industrial climate baseline. They also found that the heat dome affected approximately 34% more area and lasted approximately 59% longer than it would have in an unwarmed atmosphere. Sit with those numbers, not the peak temperature, the area and the duration. The warming did not just push the thermometer up, it made the structure larger and more persistent. It reached into exactly the two dimensions, geographic spread and duration, that determine how many people cannot escape and how many nights pass without recovery. A 1 in 10,000 year event in the pre-industrial climate, becoming 150 times more likely, is not a minor statistical nudge. It turns an event that a civilization could reasonably consider once in recorded history into an event that becomes plausible within a human lifetime, and then plausible within a generation, and then plausible within a decade, depending on how far the warming continues. This is the return interval problem, and it is the actual reason the question in this analysis's title deserves to be asked even when the answer for this specific weekend is clearly no. Part 11. The rising floor. The clearest way to understand what is happening to the frequency of extreme heat events is through the concept of a temperature distribution. Think of every possible summer day in a given location as a point on a bell curve. Most days cluster in the middle, the typical summer temperatures that define the region's character. Days get progressively rarer toward the extremes. A day at 1 standard deviation above average happens with moderate frequency. A day at 3 standard deviations above average happens rarely. A day at 5 standard deviations above average, sitting far out on the tail, might happen once in many decades, or once in a century. Now take that entire distribution, the full bell curve, every day from coolest to hottest, and slide it 1.5 degrees to the warmer side. The shape of the distribution does not change. The variability from day to day does not change. But the absolute position of every point on the distribution shifts warmer by that amount. The practical consequence: temperatures that previously sat far out on the rare hot tail, the 3 standard deviation days, the once-in-a-generation extremes, now sit closer to the middle of the distribution, where events happen with much greater frequency. An afternoon that was a once-in-a-1,000-year reading on the old distribution might be a once-in-a-100-year reading on the shifted distribution, and a once-in-a-100-year reading might become a once-in-a-decade reading. Nothing dramatic has to happen to the atmosphere's internal variability for this shift to produce dramatically more frequent extreme events. The day-to-day weather patterns can remain exactly as variable as they have always been. The jet stream can meander in exactly the same ways it always has. The only change is the floor underneath it all, the baseline temperature from which every deviation is measured. The global average surface temperature has risen approximately 1.3 degrees Celsius since the pre-industrial baseline. That is not a large number in the context of daily weather variability, but it is enough to substantially shift where the extremes fall in that distribution. It is enough to convert a 2021 scale event from something that belonged to the extreme tail into something that belongs further toward the body of the curve. The attribution scientists who studied 2021 were not making a political argument when they estimated the warming had made it 150 times more likely. They were measuring how far the distribution had already slid. A factor of 150 is enormous. It is the difference between an event that a civilization could expect, perhaps once in many centuries, and an event that could plausibly occur within a single generation, and the floor keeps rising. Whatever its level was in 2021, it is higher now. Whatever level it reaches by 2030 or 2040 will be higher still, depending on how much additional warming accumulates. Each increment of warming further shrinks the return interval for events that sit at a given position on the distribution. This is not a prediction about any specific future event. The jet stream will continue to vary unpredictably from year to year. Some summers will be cool, some will be hot, by the natural variability of the atmosphere, but the floor those variations occur on will be higher, and the extremes they occasionally produce will be further into previously unexplored territory. The Pacific Northwest will not face a 2021 scale event every year, but it will face such events more often than it did in the past. And with each increment of warming, more often becomes a smaller interval, the question of when, not if. Part 12. What to actually do this weekend. The practical implications of this analysis for the coming days are specific and worth stating directly, without the hedging that makes weather communication useless. If you're in the Pacific Northwest and you do not have air conditioning, which describes a substantial majority of residents, the cool nights are your defense and you need to use them actively. This means opening windows and doors after the temperature drops in the evening and actively drawing the cooler outside air through the house. It means running fans to accelerate that exchange. It means closing the house back up in the morning before it warms again, so that the cool you drew in overnight is preserved as long as possible through the afternoon. The passive assumption that the house will cool itself is less reliable than active management. The forecast overnight lows in the mid-50s to low 60s represent a meaningful opportunity. A house that drops to 55 at its coolest point overnight is a significantly more manageable environment at noon the next day than a house that never dropped below 70. The cooling is there. Using it requires active behavior, not passive assumption. If you are older, or live alone, or have a medical condition that affects heat tolerance, or take medications in the categories that blunt thermoregulatory response. The moderate heat risk classification is not bureaucratic caution. It is a direct description of the population for which this weekend's temperatures are genuinely dangerous. Know where your nearest cooling centre is. Go there for the afternoon hours if your home becomes uncomfortable. Drink fluids whether or not you feel thirsty, because the sensation of thirst becomes a less reliable signal in heat stress. If you have elderly neighbours or relatives who live alone and may not take a low 90s forecast seriously, contact them. The demographic pattern in 2021 deaths was clear. People living alone, in homes without cooling, who were not in contact with anyone who would notice their deterioration. That pattern is preventable at the individual level by the simple act of contact. The heat risk for this weekend is real and specifically located in overlapping groups of people. Older, isolated, medically vulnerable, without air conditioning, whose situations make a 91-degree day with poor overnight cooling in the house into a genuine physiological threat. For the general, healthy, air-conditioned population, this weekend is a warm spell. For those specific populations, it requires active management. The cool nights, if used, make this manageable. The cultural habit of not taking heat seriously in a region that has historically not needed to is the variable that kills people even in manageable events. Part 13. The distance between two identical skies. Stand back now and look at the whole picture. Two ridges of high pressure, both building over the same stretch of the Pacific Northwest, both pushing the marine air offshore, both connected to a buckled jet stream holding a blocking pattern over the continent, both producing early season heat on a population without air conditioning and without acclimatization, both generating forecast discussions that include the word record. From far enough away on a weather map, they look like the same feature. A meteorologist seeing the two maps without context might not immediately identify which produced the worst natural disaster in the region's modern history and which produced a warm weekend most people had forgotten about by the following Friday. The distance between them lives in three variables that do not appear at a glance: the amplitude of the ridge, how high it built, how warm it forced the air aloft; the persistence, how many days it held before the marine air returned; and the overnight temperatures underneath it, the single most consequential number in the forecast, the one that determines whether the body gets a reset or compounds toward crisis. In 2021, historically extreme amplitude, a week of locking, nights that never cooled. Every one of the 3 lethal variables set to maximum. This weekend, moderate amplitude, 2-day duration, nights in the mid-50s. Every one of the 3 lethal variables set to manageable. The underlying vulnerability that makes the region susceptible to the lethal version, the housing stock, the cultural calibration, the physiology of June, is identical in both cases. The tinder is the same tinder. The only variable is whether the ridge is a small match or a blowtorch. This weekend it is a small match. 2021 was the blowtorch. Knowing the difference requires understanding the 3 variables, amplitude, persistence, overnight lows, and knowing how to read them in real time from the forecast. That is the skill that separates a person who can assess their actual exposure from one who is either permanently alarmed or permanently dismissive, depending on which bad faith version of weather communication they have most recently been exposed to. The correct response to this weekend is, take it seriously without panic, open your windows at night, check on vulnerable neighbours, hydrate. Understand that the cool nights are doing the protective work and take advantage of them. The correct response to the broader trajectory is, understand that the floor underneath every future ridge keeps rising, that the distance between the small version and the lethal version is shrinking, and that the region's standing vulnerability, the structural absence of air conditioning, the early season timing of June, the concentrated risk in older isolated populations, does not heal between events, it waits. The next time a ridge builds over the Pacific Northwest and the forecast discussions start reaching for extreme language, temperatures aloft that leave the historical range, model guidance showing a lock extending beyond a week, overnight lows forecast to stay in the 70s or 80s, heat risk classifications climbing to extreme across broad regions. Those 4 signals together describe a situation where the answer to the title question flips, not this weekend. But on some weekend, at an interval that is not fixed and not as long as it used to be. Until that weekend, the right posture is the one the data supports, informed attention without manufactured panic, and the ability to tell the difference between a warm spell and a catastrophe using the actual numbers rather than the loudest voice in the room. The Pacific Northwest will be fine this weekend. The marine air will return, the temperatures will fall. By the following weekend, most people who lived through it will not think of it as a weather event worth remembering. But the region is one tall, locked, warm-nighted ridge away from reliving its worst week at any time the atmosphere chooses to build one, and the atmosphere is building on a floor that is, year by year, less forgiving of the times it does. That is the truth the question in the title is really asking about, and the honest answer is, not this time. But the interval between the times we have to ask is getting shorter. And the region that answers no today is the same region that answered no in June of 2019 and in July of 2020, and then said nothing at all in the final week of June 2021 because the answer had finally changed. The only thing standing between no and yes is the character of the next ridge. Watch the overnight lows,